China has sent spacecraft to the moon more times in the last 15 years than the entire rest of the world combined. Not one or two missions. We are talking orbiters, surface landers, rovers that crossed kilometers of gray dust, a relay satellite parked in deep space behind the moon, and a vehicle that physically collected ancient rocks from the far side of the lunar surface and carried them all the way back to Earth. No other country has done that. Not the United States, not Russia, not anyone. And here's what most people still do not understand. None of those missions were the goal. Every single one of them was a step. A carefully planned, precisely executed step towards something far larger than a science experiment or a national pride moment. China is building a permanent human presence on the moon. Not someday, not theoretically, right now, with hardware already tested and missions already locked into a calendar. By the end of this video, you are going to understand exactly what they are building, why that particular location on the moon matters more than anywhere else in the solar system, and why whoever gets there first will hold an advantage that shapes the future of human civilization for the next 100 years. If this is the kind of story you come here for, hit like and subscribe before we go any further, because this one is worth having in your feed. Let us get into it. The plan that most people missed. Most countries approach the moon the way a tourist approaches a new city. They show up, look around, take some photos, and go home. China approached it the way an engineer approaches a construction project. You do not start with the building. You start with the survey. You study the land, test the ground, and understand every variable before you commit to anything permanent. Back in the early 2000s, China laid out a lunar program with 4 distinct phases. Phase 1, orbit the moon and map it. Phase 2, land on the surface and study it up. Close. Phase 3, collect physical samples and bring them back to Earth. Phase 4, build something that stays. Each phase had to succeed completely before the next one began. Nothing was rushed, nothing overlapped. Think of it like learning to drive. You do not start on the highway. You start in an empty parking lot, then quiet streets, then city traffic, then the open road. You build the skill before you raise the stakes. In 2007, Chang'e 1 circled the moon for over a year and produced some of the most detailed maps of the lunar surface ever made at the time. No landing, no rover, no headlines about astronauts. Just methodical, precise data that scientists could use for years to come. 3 years later, Chang'e 2 went back and sharpened those maps further. Resolution good enough to study individual craters and slopes and determine exactly which patches of ground were stable enough to land on. Most people never heard about either of these missions. They were not dramatic, but they were essential, because without those maps, none of what came after would have been possible. And what came after changed what scientists thought they knew about the moon entirely. The discovery that rewrote the textbooks. In 2013, China did something no country had managed in nearly 4 decades. Chang'e 3 made a controlled landing on the lunar surface. The last time any spacecraft had done that was 1976. The world had essentially stopped going to the moon. And then, quietly and precisely, China went back. A small rover named U2, which means Jade Rabbit, rolled onto the dust and got straight to work. Within days, it found something nobody expected. The rocks were different. For 50 years, the scientific understanding of lunar geology had been built almost entirely on samples brought back by Apollo astronauts. 12 people, 6 missions, a small cluster of landing sites on the near side. Those samples were studied, cataloged, and used to construct a complete picture of what the moon is made of. Textbooks were written. Academic careers were built on those findings. The story felt settled. It was not settled. U2's instruments found a type of volcanic basalt with no match anywhere in the Apollo collection. The mineral composition was different. The chemical fingerprint was different. It was like reading an entire book about world cuisine that covered only French cooking, and then discovering that most of the planet had been eating something completely different all along. What this told scientists was enormous. The moon is not a simple, uniform rock. It is geologically complex, with regions that formed through different processes at different times. The Apollo landing sites were not representative of the whole surface. They were 6 data points on a map with millions of unexplored locations. And if the places already visited were producing surprises, what could possibly be hiding in the places no mission had ever reached? Direction for everything that followed. Going where no signal could reach. Here is something worth thinking about. You have looked at the moon your entire life. Every full moon, every crescent, every disk hanging low on the horizon. And every single time, you were looking at exactly the same face. The moon rotates at precisely the right speed to keep one side permanently facing Earth. The other side, the far side, always points away into deep space. No telescope on Earth has ever seen it, and landing a spacecraft there had long been considered basically impossible. The moment a lander touches down on the far side, it loses all contact with Earth instantly. No line of sight, no radio signal can bend around the moon. It is like trying to have a phone conversation with someone inside a sealed vault with walls 1,000 kilometers thick. China solved this with an approach that was genuinely elegant. Before launching the lander, they sent a small relay satellite and parked it in a precise orbit beyond the moon where it could see both the Earth and the far side simultaneously. Commands from Earth traveled up to the satellite passed them down to the lander, and data came back the same way. Simple in principle, extraordinarily difficult to execute. In 2019, Chang'e 4 became the first spacecraft in history to land on the far side of the moon. It touched down inside the South Pole Aitken Basin, one of the largest and oldest impact craters in the entire solar system. More than 2,500 kilometers across, that single crater is roughly the size of Western Europe. Scientists believe it is so ancient and so deep that the original impact may have punched through the moon's outer crust entirely, exposing material from the lunar interior that has not been near the surface since the moon first formed. Then in 2024, Chang'e 6 landed in that same basin and did something that had never been attempted from the far side before. It collected nearly 2 kilograms of ancient soil and rock, sealed them into a container, launched a small ascent rocket off the lunar surface into orbit, docked with a waiting spacecraft overhead, and flew the samples all the way back to Earth. Every one of those steps had to work perfectly. None of them had ever been tried from that side of the moon, and every single one worked. The rocks that came back were approximately 2.8 billion years old and showed evidence of volcanic activity far later than scientists had predicted. The moon was geologically alive for much longer than anyone had realized. Its story is stranger and more complex than the textbooks ever captured. But here is the thing. As remarkable as all of that science is, those missions were still not the main event. They were preparation. The real target is somewhere else entirely, and understanding it requires understanding something that has been sitting frozen in the dark for over 1 billion years. What is buried in permanent night? Find the very bottom of the moon on a clear night. That is the South Pole. The moon barely tilts on its axis, so sunlight hits the South Pole at an extremely shallow angle, almost parallel to the surface. In that geometry, the walls of deep craters near the pole block every ray of sunlight from ever reaching the crater floor. Not seasonally, not occasionally, permanently. Some of those crater floors have been in total unbroken darkness for more than 1 billion years. No photon of sunlight has touched them since before complex life existed on Earth. Inside those craters, temperatures drop to around -200 degrees Celsius. Colder than the surface of Pluto. one of the coldest natural environments in the entire solar system, sitting just 384,000 kilometers away. And scientists believe those freezing, lightless craters are full of ice. Over billions of years, comets and asteroids carrying frozen water slammed into the moon. Most of that water evaporated in sunlight and drifted away. But in those permanently shadowed craters at the South Pole, the temperature never rose high enough to release it. So it stayed, frozen, perfectly preserved, waiting, like food kept in the back of a freezer that nobody ever opens. Now think about what water actually means in space. Water is made of hydrogen and oxygen. Oxygen is what humans breathe. Hydrogen is one of the most powerful rocket fuels ever developed. If you can mine that ice, heat it, and split it apart chemically, you get breathable air and rocket propellant. Both of them, from the same source. On the moon, no supply ship required, no resupply mission from Earth. Here is why that changes everything. Getting anything off Earth's surface is enormously expensive because our planet's gravity is powerful. You need a massive rocket just to reach orbit, let alone travel beyond it. Every kilogram launched from Earth carries a staggering cost in fuel and engineering. The moon's gravity is about 1/6 of Earth's. Launching from the moon requires a fraction of the energy, which means launching fuel from the moon into space costs a fraction of what it costs from home. If you could produce rocket propellant at the lunar South Pole, the moon stops being a destination. It becomes infrastructure, a refueling station sitting right next to Earth. Spacecraft heading to Mars could stop at the moon, fill their tanks, and continue outward. Missions going to the asteroid belt or the moons of Jupiter could do the same. The moon becomes the world's first off-planet supply depot. And whoever builds that depot first does not just gain a scientific advantage. They gain the ability to shape how every mission beyond Earth is planned, routed, and funded for generations to come. This is the real reason China keeps going back. This is what every mission has been working toward. The robot built for the darkness. To confirm that the ice is there and understand how much of it exists, you cannot orbit above and make educated guesses. You have to go into those shadowed craters directly, but they are pitch black. Solar panels are useless without sunlight. And the terrain inside is rough and completely unpredictable because nothing has disturbed it for 1 billion years. A standard rover would run out of power almost immediately. China's answer is Chang'e 7. Currently scheduled for launch in 2026, this mission carries something that has never been deployed anywhere in the history of lunar exploration: a probe that jumps. Instead of rolling on wheels, this small hopping vehicle can leap off the surface and land directly inside permanently shadowed craters. It carries instruments to detect water molecules in the air and soil, identify hydrogen signatures underground, and analyze frozen material embedded in the crater floor. It goes in, does the work no other machine can do, and gets out. Think of it like the difference between trying to drive a car into a narrow cave versus sending in someone specifically trained and equipped for exactly that environment. The full Chang'e 7 mission also includes an orbiter mapping the South Pole region from above, a lander on stable sunlit ground near the pole, and a surface rover scouting targets for the hopping probe. 4 components working as one coordinated team. If Chang'e 7 returns with confirmation of substantial water ice deposits in those craters, it will rank among the most consequential discoveries in the history of space exploration, not just scientifically, practically, because it proves that everything humanity needs to live and work beyond Earth has been sitting there the entire time, perfectly preserved, billions of years old. And confirming the water is only the first step. Learning to build from nothing, finding a resource and actually using it are 2 completely different things. To establish a functioning base at the lunar South Pole, you need technology that can survive with no atmosphere, extreme temperature swings, constant radiation bombardment, and a fine dust that works its way into every gap and joint in every machine you bring. You need systems that operate for months without any human hand adjusting them. You need, essentially, to learn how to build on the moon using only the moon itself. That is the central mission of Chang'e 8, planned for around 2029. This mission is entirely focused on in situ resource utilization, a technical phrase for a simple idea. Use what is already there instead of shipping everything across nearly 400,000 kilometers of empty space. One set of experiments will attempt to heat and compress lunar regolith, the loose surface material covering the moon, into solid structural blocks. Like baking bricks, except instead of clay from a riverbank, you are using the same gray powder that covers every square meter of the lunar surface. Those bricks could build landing pads, radiation shielding walls, and roads for rovers. Other experiments will test extracting oxygen directly from lunar minerals, which are chemically rich in oxygen but need the right process to release it. And some designs involve robotic systems that use lunar material as feedstock to 3D print structural components, building up walls and domes layer by layer before any human crew ever arrives. If these technologies work in the real lunar environment and not just in a lab on Earth, the implications are significant. You would no longer need to launch construction materials from home. The moon would help build itself. And once those building blocks are proven, the project that everything has been leading toward finally becomes possible. The station that changes everything, every orbiter, every lander, every rover, every sample return, every construction experiment. All of it feeds into one single endpoint, a permanent research station at the lunar South Pole. China calls it the International Lunar Research Station, the ILRS, and it is one of the most genuinely ambitious infrastructure projects ever seriously proposed by any space agency anywhere in the world. Construction is planned to begin in the early 2030s. Robotic missions arrive first with power systems, communication towers, and laboratory modules. Machines do the dangerous early work long before any astronaut boards a rocket heading that way. Over several years, the station grows, module by module, until it can support human crews for weeks at a time, then months. Then those monthly rotations become the baseline, and what started as an outpost slowly becomes something that no longer needs to be called temporary. China is not building this alone. Dozens of countries have already signed agreements or expressed formal interest in contributing equipment, experiments, and personnel to the ILRS. Russia, Pakistan, South Africa, Belarus, Venezuela, and others are already part of the framework. More nations are in various stages of discussion. This means the ILRS is not a purely Chinese installation. It is, by design and by explicit invitation, a shared human presence on another world. China provides the foundation. Other nations build on top of it, and that is a deliberate strategic choice. The country that builds the foundational infrastructure gets to establish the standards, the protocols, and the operating norms for everything that happens there. The way the United States once set the technical standards for the internet, China is positioning itself to set the terms for the first permanent human settlement beyond Earth. That is a legacy that outlasts any individual political moment by a very long margin. On the crewed mission side, the hardware is being tested right now. The Long March 10 rocket, capable of lifting around 27,000 kilograms to lunar orbit, completed a key test flight in early 2026. The Mengzhou crewed spacecraft passed a critical emergency abort test around the same time, proving it can pull a crew safely away from a failing rocket during launch. These are not minor milestones. They are the tests that determine whether a program is ready to put human lives on top of it. Each crewed lunar landing will require 2 launches. One carries the crew, the other carries the lander. They meet in lunar orbit, dock, and 2 astronauts descend to the surface. First visits will last only days, but those short stays are not the destination. They are the proof of concept. The moment when everything that has been planned, simulated, and tested in facilities on Earth becomes undeniably visibly real. Because once people can land on the moon and come home safely, the only question left is how long the stays can grow. And the answer to that question depends entirely on what gets built at the South Pole in the years before those astronauts arrive. Why this spot, and why it matters so much. It is worth pausing to understand why the South Pole, specifically, is the target. Because there is a reason every serious spacefaring program, including the United States with Artemis, is focused on exactly the same region. At the South Pole, you have permanently shadowed craters that may hold billions of tons of water ice. Crater rims that receive near-continuous sunlight for solar power generation. Raw material to produce fuel, oxygen, and building structures directly on site. Ancient deep geology for scientific research that no mission has ever touched. And a position in space that makes it the natural staging point for any mission heading further into the solar system. Everything you need, concentrated in one region. Water for life support and propellant production. Sunlight for power. Ancient rock for science. And a gravitational environment that makes launching from the surface far cheaper than doing it from Earth. The first nation to establish a working, permanent presence there does not just win a prestige competition, it gains an operational advantage that builds on itself over time. Every mission launched from the moon is cheaper than one launched from Earth. Every international partner brought in deepens its centrality to the whole architecture of future human space activity. Think of it like being the first nation to build a deep-water port on a critical trade route. Once the port exists, commerce flows through it, ships stop there, supplies move through it, relationships form around it, and whoever controls that port shapes every transaction that passes through for generations. A story still being written. Here is the perspective that puts all of this into proportion. 12 people walked on the moon between 1969 and 1972. 6 missions. A small cluster of landing sites, all on the near side, all in a relatively narrow band of the surface. And then nothing for more than 50 years. The moon became a closed chapter. A remarkable achievement that humanity filed away and moved on from. The textbooks were written. The story was declared finished. What the science of the last 15 years has confirmed is that the chapter was never actually closed. It was barely opened. The Apollo sites were not representative of the whole surface. They were 6 data points on a map with millions of unexplored locations. The geology is more complex than we knew. The far side holds rock that has not been near the surface since the moon first formed. The volcanic history ran longer and stranger than any model predicted, and the resources sitting in those permanently shadowed craters at the South Pole, the ice, the hydrogen, the oxygen, were completely unknown to the scientists of the Apollo era. Every mission China has flown since 2007 has added a new layer of understanding to a story that turned out to be far richer than anyone had appreciated. And each new layer has made the next mission more necessary, more targeted, and more consequential. China did not walk away from the moon. It landed rovers. It reached the far side. It returned ancient samples. And it is now building the rockets, the spacecraft, the robots, and the international partnerships to establish a permanent presence. Not because the moon is the endpoint, but because it is the beginning. The first rung on a ladder that leads to Mars, to the outer planets, to distances and timescales that are difficult to even frame from where we stand today. Every outpost ever built at the edge of the known world started as an act of preparation, a forward position for the next reach outward. The port before the trade route, the base camp before the summit, The lunar South Pole is that for humanity's next chapter, and right now, mission by mission, test by test, module by module, the foundation is being laid on a surface that once looked like a finished story. The moon was never finished. It turns out the real story had not even started yet. If this gave you something to think about, hit that like button and subscribe so you never miss what we cover next. Turn on notifications because this story is moving fast and we will track every major development as it happens. Now I want to hear from you. If the ILRS opens to international researchers in the 2030s and you had the chance to spend 6 months stationed at a base on the lunar South Pole, would you go? Drop your answer in the comments below. I read every single one.